Right, so we are going to actually solve the quadratic, and the quadratic is an equation that can be used to model, a particular phenomenon in the real world. Okay, the question says solve the following equations, and all of them are quadratics. You will identify a quadratic when there is a little 2 above an x. Okay, so that's how you will know it's a quadratic. So therefore now, last class we talked about the number of roots. So we can recall, let's do a recall there right away. Recall. Let's do it in point form. Okay. As a form of introduction. Last class, we determined. Okay. Can anybody tell me what we determined last class? You're not seeing my screen, so I'm going to share my screen. I'm going to share my screen with you all right now. Okay, so can anybody tell me what we did last class? Revise your notes. Quickly watch the video again. Check it out. It's on the WhatsApp group chat. What did we do last class? Last class, what did we determine? We determined the number of roots. We determined the number of roots. Someone said the determinant. No, we did not determine the determinant. So you see, it's like a tongue twister right there again. We did not determine the determinant. Okay. Last class, we determined the number of roots. That's what we determined last class, the number of roots of a quadratic. And just a reminder of our quadratic looking like. But keep that thought there as you say the determinant. I'm going to mention the word, but it's not the determinant we determined last class. We determined the number of roots, okay, of a quadratic. And that's how a quadratic looks like. The general form of a quadratic: ax with a little 2 on top, on the top right corner, x squared. When you see a little 2 up there, you say square. Ax squared plus bx plus c. Okay, that's how you'll be able to identify a quadratic. Once you see a little 2 on the top right corner of the x or any letter, that's a quadratic. Here is a 3, then it's a cubic. Okay, but we're talking about quadratic. Oh yes, you can put the equal, not necessarily, but you can put the equal 0. Okay, but not really necessary here. All right. So we determine the number of roots of a quadratic by using, all right, by using the determinant. Okay. So someone said we determine the determinant, not necessarily the discriminant. Sorry. Thank you very much. Okay, so we did not determine the discriminant. We used the discriminant to determine, all right, the number of roots. That's what we did last class. Okay, and what is the discriminant? Yes, the discriminant. B squared minus 4ac. B squared minus 4ac. All right, that's the discriminant. Agreed? So that's what we did last class. Okay. So now, presently, all right, presently we are going to okay, so today, presently, we we can put in point form again. For today, this session, we are going to solve the quadratic. That's what we are going to do today. Solve the quadratic. Right. Now we must put the 0 equals 0. Eh? This is solve the quadratic. We must put it equals 0. In other words, what does it mean to solve the quadratic? In other words, we are going to, determine the value of the roots themselves. We are going to determine the actual value of the roots. So last class we determined how many of them, 0, 1, or 2. But now we're actually going to find them. All right, we are going to find them. We are going to find the roots. Or solve for them. Okay, so that's why the question says solve the following equations. Okay, find what the roots are. Okay, so for example, solve the equation. All right, and as you can see, as it's the equation, we must have the equal sign. So you must have equal 0. You cannot solve an expression. You see, we cannot solve that. All right, if I put, let's say I put 5 there. Yes, now let's say I put 5 there. In the place of A, I put 5. In the place of B, I put 9. In the place of C, I put negative 12. I cannot ask you to solve that. No mathematician has the right to ask you to solve that. They will not be making any sense. This is an expression. You cannot solve an expression. You cannot find the value. You can only solve an equation. So it must have the equal 0 if you are told to solve the quadratic. It must have the equal 0. Okay? Must have the equal 0. All right? Because what we are actually going to find is that. I'm going to show you what we're actually going to find. This type of quadratic has no roots. So this one cannot be solved. There are no real roots for this one. This one, when you solve it, you're going to get one root, one number, because it's touching the x-axis only once. And remember, you can remember on the x-axis, which letter is equal to 0 on the x-axis? Anybody? Can you recall? X or Y, which letter is equal to 0 on the x-axis? Anybody can recall which letter, X or Y that is equal to 0 on the x-axis? Anybody? Y is equal to 0 on the x-axis. Remember, we say try to switch the letters when you are doing that kind of analysis. X is 0 on the y-axis, Y is 0 on the x-axis. Okay, so we're going to, Y is always 0 already, so that is why now you have, when you come to this, it says equal to 0, because initially it was equal to Y. Y is equal to, isn't that so? But now you have equal to 0. So you make Y 0 and you want to solve for X. Right? You want to solve for X, you see that? X, which X? Here we have a 1 there. what is the x value for y to be 0? That's what is going on. So in a case like this, you'll have one value for x when y is 0. And in this case now, you're going to get two values for x. You see the x? Two values for x. All right? When y is equal to 0, for a case like that. You see where the parabola touching the x-axis twice. The parabola is touching the x-axis twice when y is equal to 0 for a situation like that. Okay, so that is what is actually going on there. All right, when they're told to solve the quadratic. Okay, so bear that in mind, and we are going to apply this to an example. All right, we are going to solve for x. X we are going to find because we already made y 0. This was once upon a time y. Now we make it 0, and we're going to solve for x. All right, so our answer going to be a number comma 0, another number comma 0. Hence, let's come back there. Therefore, always put a comma after therefore our solution. All right, our solution will be in the form a number, let's call it x, comma 0. Okay, that's our answer will be x, comma 0. It could be 1 or 2. Okay, x, comma 0, because we made y 0, we made y 0. All right, look at that, we made y 0, x, comma y, we made y 0. We're going to solve for x. So here's an example, which we're going to get, just by inspection, we're going to get 2x values, because I purposefully made the y-intercept c negative. I say I put a negative 12 there. So I deliberately put a situation where the parabola comes right down, touching the y-axis on the negative side. So therefore, we must get 2 x values for this example that I put. Okay? If you want, you can rapidly determine how many roots, and you know you're going to get 2 of them. I repeat, if you want, you can rapidly determine how many roots, and we're going to get 2 of them. In fact, we're going to do it. Just to recall from last class.